number's negative, and we are probably what? Multiplying. If you didn't do that, that's 18 minus 3/2. You're going to be very confused. So put your parentheses around that negative number, the way we did, but also never forget to do what? Switch the what? The signs. So you don't want to forget to switch those signs. I put it in red. Maybe you want to go to Home Depot, or not Home Depot, sorry. I'm thinking of other things. You go to Home Depot. You want to go to, where do you buy markers? Don't go to the campus bookstore. They'll double charge you. Go where? I don't know where you go. Get a red marker, and when you do your homework, do what? Put that in red. Anyway, okay, you ready? What's negative times a negative? It's positive, right? So, and also, you guys remember, what's 3 over 3 is gone? Cancels, or we just say this whole portion is 1. So you got x. Make sure we switch the sign automatically. X less than or equal to. Now, what's a positive times a negative? What's 18 multiplied to? 3 or 2?
3.
What's 18 times 3?
54.
Good. 54 divided by what number? 2. What's 54 divided by 2? Negative. Well, the sign is negative. 27. Good. Here's your solution. Okay. X less than or equal to what? Negative 27.
Good.
So then now, let's see what happens with this. If I had to describe this in terms of a set of all x such that x is less than or equal to negative 27. Okay, and then now, let's graph this. 0 is in the center. Negative 27, the reference number is where? It's negative, so that's where? To the right or the left? So we get negative 27. Open circle. Shade everything in what direction? To the left or to the right? To the left. Is that right? Why is it to the left? Numbers less than negative 27. Numbers that are less than are numbers that are smaller than. Smaller numbers live where? To the left are smaller numbers. To the right, larger numbers. Further to the right you go, the bigger the number. Further to the left you go, the what? Smaller the number. That's how we're looking at it. Do we shade in the circle?
No.
How do we shade it in? How do you know? Equal. Shade that in. Good. Okay, and then we write our interval notation. We're almost there. We start from the left always and work our way left to right. We're walking left to right. Are your feet wet?
Yes.
Your feet are wet.
Yeah.
Where does it start to get wet? Well, started already. This goes on forever to the left. Negative infinity up to negative 27. Parentheses. What is this? Bracket. Set, graph, and by the way, you're looking back at the book, this book, like college level textbooks, they don't use the bubble being shaded or open. They will borrow from that concept of a square bracket, and they want to symbolize what? They're symbolizing that we include the negative 27. The reason we include it is because they said to include it by providing us with the what? That equal portion here. So this is x, or numbers less than negative 27, or equal to what? Negative 27. Okay? You guys okay with this? All right, let's see if you're awake. This stuff's easy. It's easy stuff. What do you really have to do, though? When do you study? The night before test? You don't study the night before. When do you study? Today, now is when you study. What do you do the night before a test?
Sleep.
Sleep. You sleep, because if you don't sleep, when you try to take a test, your brain's gonna what? It's gonna say, I'm tired. You're gonna blank out. I guess, well, never mind. Okay, let's try this out. What do you guys think? What are you going to do? Multiply or divide both sides? Divide. Why do you know to divide? What's happening to x? We have to undo some multiplication. So you divide, and then what do you know? Oh my God, what do you guys know? What numbers multiply to x? So we have to divide both sides by that -2. So what I want to show you here is what's going on here. This goes away, and you get what? X. What's happening with that less than sign? It switches to what? Greater than. And then what do you have? 1/7. I want to emphasize this concept right here, because people look at this and they're not quite sure what to do. I know you guys are sure because we covered that kind of thing in review. So let's remind you here. What do you guys notice? This here is a vertical definition of division. Is that true? So I'm going to write this horizontal. 1/7 is on top. We put it on the left. That sign is what? Division. By what? I put that in my parentheses to emphasize that that number is what? Negative. So now you guys have to remember you have x, okay? It's still what? We switched the sign already. What does it mean to divide? You're going to do what? This is 1/7 now times what? Well, wasn't this -2 over what? Over 1? So it's going to be now what? 1 over, is it +2 or -2? -2. Because that 2 doesn't change signs just because we flip it over. And then now, how do you multiply fractions? Straight across, you get x is greater than, what's 1 times 1? What's 7 times -2? -14. So we get x is greater than negative what? 1 over what? 14. Here's your solution. Let's write the graph. 0's in the middle. -1 over 14, where's that at? To the left or to the right? -1 over 14. Now, what do you guys know? We're describing numbers that are what? Greater. Greater than this number. Numbers that are greater live where? To the right or to the left? Right. We got to write the set notation. Set of all x such that what? X is greater than 1 over 14. What about your interval notation? How do we describe that? Let's walk from left to right again. Do we start with our feet in water? No, only up to what? Well, really not at -1 over 14, not at this number. A little bit more to the what? To the right. We just list it. Put your parentheses to indicate that it doesn't really start at that -1 over 14. It starts a little bit what? Further. To the right. And then, where does this end? Our feet are in water, right? This goes up to what? Infinity. Here's your interval notation. So we got all three of these concepts here in describing our solution. And again, by the way, looking back at the book, they may not have that bubble. They may have what? Parentheses. Interval, or graph, interval, and what? Set. We've got to keep doing some more. Let's do some more examples for you guys. Here we go. Let's look at number 19. Okay. 19. What do you have? Negative 12 minus what? 4x plus 8 greater than or equal to negative 5x plus 3. Let's try to use all these ideas if we could.
I have a quick question.
Yeah.
You switch the sign when you multiply or divide, right?
By a negative. By a negative. Yeah. I mean, there's another situation where we switch the signs. And I'll do a problem like that. But there is kind of one, it's really not switching in the same way, but you'll see what I'm talking about. So we'll look at another example after this one. Maybe this one will, how about we do this? Well, maybe we'll do it, okay, we'll do it the other way. Again, what are you guys used to seeing again? X on what? One side. Is that true? Okay, so you're going to translate this. Or before you do that, let me remind you, before we even translate, notice this problem is kind of funny in a sense. Can I combine my negative 12 and my 8?
Yeah.
You know, because sometimes they give you problems like that, especially on the worksheet. So negative 12 plus 8, isn't that negative 4 minus 4x greater than or equal to negative 5x plus what? 3? Okay, and then what? Now we do our translation. We want our x's on one side. We're going to translate this. So that negative 5x on the right becomes what? Positive 5x on the left minus a what? 4x. What do you guys notice about that sign? Switches. And then what do you have here? This is 3. We didn't move the 3. We moved the negative 4. So it's now what? Positive 4. So what's 5x minus 4x? X. Less than or equal to, what's 3 plus 4? 7. Here's our what? Here's our solution. Set of all x such that x is less than or equal to 7 as set notation. We go and we graph this again. Okay, here's our graph. Here's 0 in the center. The reference number of 7 is positive, so it's to the right somewhere over here. It's a closed circle because we what? Include the 7. Now we're describing numbers that are what? Smaller or equal to 7. Numbers that are smaller than the 7 live where? To the left. So we shade everything to the left of that 7. And we included the 7 because it's equal. Here's your graph. How does the interval notation look? Question? No? How does that interval notation look? Yes?
I thought you said that it only changes when you divide it by a negative.
That's true.
So how is it really divided by a negative?
Did we divide by a negative?
No.
Yeah, so we did it. Oh, thank you. Oh. Thank you. I'm thinking of. Oh, you guys don't want. You guys don't want to know what I'm thinking of. Greater. Thank you. Why did we switch that?
So only when you multiply and divide a negative.
Write that down. Get a tattoo. What are you going to tattoo? Only when you what? Oh, I think I erased it. Now, how does that change everything? It sure does. What happens when you shade this? There you go. 0's in the middle. Where's 7? To the right or the left? Shade everything in what direction? To the right. Why to the right? Because we're describing numbers that are what? Greater than the reference of 7. Numbers that are greater live to the right. And then how does that interval notation look as you walk left to right? Where do you start with again?
7.
You start with 7. Do we include the 7?
Yes.
So put a what? Bracket. Good. And you go all the way up to infinity. You're looking back in the book, though. If you graph, you're probably going to see the square bracket here. They're not going to bubble that in.